Okay. Let's talk about mirror alignment. As I received lots of feedback on my last video where I said that my K40 laser has certain sweet spots in the laser bed where it performs best, you guys gave me plenty of input of what could be wrong with my unit. Well, first of all, after almost 5 years, I never swapped or upgraded the mirrors that came with the machine. Of course, I realigned them multiple times and also upgraded the lens and the laser head to this blue laser head with this air assist input, but still it always took me multiple passes when cutting. I usually use a speed of 50 millimeters per second at 50 milliamps, and yes, I use standard plywood from the store, no special laser cutting wood. But since you guys told me that most of you are using regular wood or plywood, uh, and for you one pass does cut through, I got suspicious that there is an issue with rather the mirrors or the alignment, or maybe even with the machine itself. So I just received a nice order today of some brand new laser mirrors for the K40. As this topic of how to swap the mirrors and realign the K40 laser is covered in hundreds of videos, I don't feel the need of covering it once more. There are lots of approaches how to get the best result, but for me personally, John Carver's video seems to be the most reliable. I would recommend you check him out. I will put the link down in the description. Let's open this up. I think I also ordered some spare batteries for my computer. So that's why there is this sticker on here. Let's see, here are the batteries. We don't need those. And we have our mirrors. Come in a nice little box. I think 20 millimeters of diameter. That's at least what my K40 uses. Maybe there are multiple models, I'm not sure. So as I said, YouTube is full of videos that shows you how to replace those mirrors and how to realign them. So let's try something unconventional today. I read about reverse calibration or reverse aligning due to an ad that showed up yesterday on YouTube as by magic. What a coincidence. So I want to find out if this is really a quicker and easier way of aligning your laser mirrors, and therefore I designed and printed me a little bracket here. Of course you can download the 3D model for free on my webpage as well. There will be two models, one for the conventional silver nozzle for the K40, or that's the one the machine comes with, and the other one is for the blue updated ones. That's the one I ordered me, I think at lightobject.com. Probably 2 or 3 years ago. I don't know if they still carrying them. Maybe they are even more spreaded now and easier to get by. Now, if you don't have a 3D printer, I experimented with some acrylics to cut me a bracket that I can assemble and then put onto the laser nozzle. Supposed to work something like this, but in the end I ended up by simply using two little where is it? Here. Two little O-rings. I cut it out of acrylic where the laser, by the way, this is a 5 milliwatt laser diode that I still had as spare for my little red dot. And this fits exactly in here, and you can clamp this in. I don't push it in all the way now, but it will straighten itself out. Basically what we are doing, we are sending a laser beam the opposite way, so through the nozzle just to your laser tube, and so as we have a visible point of light, it might make things a little bit easier. I would suggest we go over to the K40 right now and let's try if this thing is worth it and if it works. Okay, I put on some nice gloves. You never want to touch the lens, of course, or the mirrors. By the way, the difference between standard mirrors and the laser mirrors is that the reflective coating is on top of that little slice of glass. The third mirror I already removed. Let me see. I think, yeah, I put it into the old original K40 laser head. Let me take this off. And I think that one is the one that is really the worst. As you can see, you have this huge area here that is all opaque. And I tried to rinse this with some IPA, some rubbing alcohol, also some acetone. But yes, this is not removable. This is definitely burned into the glass. Also, this is nothing new. I knew that, so I I turned around the mirror in a way the laser hits up here, and this still seems to be fine. But of course, this can be one of the reasons why the laser power got weaker and weaker the further away I got from the actual laser tube, just because yeah, of the alignment and the convergence. I don't know. That's a German word, isn't it? Let's see. They're nicely vacuum sealed. Do we have a hiss? No hiss, as a particular YouTuber would say. No hiss. They're nicely wrapped in some paper. Let's see. Okay. They're the same size. They're definitely thicker. Well, I really should not touch the surface of this. Maybe I should not unbox these all together. I should unbox these one after each other and put them inside of the machine. Put this in here. Now guys, if you have an idea or tell me what you do to prevent the mirrors from scratching up in the mount. Do you put anything beneath the mirrors, like maybe even this piece of paper here? Do you put this in there to protect the mirror, or do you just screw them in like I do? So next will be the laser head. As I said, for demonstration purposes, I will use the original one, as I think that more people have this one than this one. But basically, as you can see, it is quite the same thing. The only difference is that the way how this thing is mounted, well, both are squeezed in between that little aluminum plate inside of the laser. But this one does not have any thread. You actually put this on here, and then you tighten this up with a screwdriver. So for this, I will take this one, so you see what I'm doing, and you can correct me if I'm wrong. So what I am pretty sure that I am, as I never said that I'm a pro in things of laser, and the whole YouTube thing just appeared to happen just like this. I made a video years ago about the K40, and it got so many views that, yeah, I just started making videos about it. And I must say I learned a lot of stuff over the years, especially, of course, because a lot of my subscribers also let me know things, and some things, but still you need really to make a lot of research to find answers, especially when it comes to the laser safety. That video I made a year ago, I was working on that for about a month or so. That was actually quite a lot of work, because I had to get in contact with that guy in Berlin from that university, and yeah, that was quite a lot of work. So most of the time I get my infos from my awesome subscribers, but sometimes I also have to make some more research, depending on what. Okay, so, well, you see it stands out a little bit. Well, it's not an issue, I think, but yeah, it's not as flat as that one, so they're a little bit thicker. Of course, there's no lens in here right now. Well, the lens would be in this other part here, in the cover. So you see this little thing there, and the lens fits in there. Also, I had problems when I replaced that lens, because the new lens is a little bit bigger, and yeah, it is bigger than this cutout, which is better in here, because this you can unscrew, and this is where your lens goes, and you see this is flat in there, so you can fit a bigger lens. But of course it needs to be It needs to be suitable for the K40 because I think it's also a big question about the focusing the focal point and the distance of your working piece. We need to adapt our little bracket here. I will screw this on, and by the way, I just found out that my red dot that is already inside of my laser machine. And now, as I said, my laser diode, I just removed the whole bracket. By the way, I made me a new bracket that I actually wanted to show you. I designed that in Tinkercad. Took about half an hour to make it, and this basically goes over your laser head like this, and then you tighten the screw and the little laser diode goes in there. You know what? I will throw this in as well. I will put this on my webpage as well, so you can download that if you want to make your own laser holder. Let's see, we have our laser diode. We put this in here, stick it in, and push it in firmly so it sits in a 90-degree angle. Then I need to put on the actual red dot. Therefore I need to get rid of all this stuff because I what did I do? Yeah, I used my bench power supply to power these, so I have to unhook them from my Knight Rider car because I'm still working on that and just finished the electronics. It's basically a little Arduino Nano and some impressively tiny little LEDs that I got from Amazon or from China. Okay, so let's put the cable in a way that we don't hang ourselves with it. Okay, let's turn this back over. And yes, we have our laser. This is good. Okay, let's put this down here like this. And then we need our top part. We screw this on. First thing I will do is I will try to hit the mirror with this laser, and we see that we are way too high. So I have to bring this side down. I have to unscrew this. Let's unscrew this. So what I have to do is I have to move this washer probably underneath the bracket. Let's see if this does something. That looks pretty good actually already. So I think with just moving this washer, we are already in a acceptable spot. Okay, now this looks pretty good. So now I can move my laser dot to more or less the middle of the mirror. By the way, I loosened up these screws already, so we are pretty much ready for realignment. I'm not a big fan of putting tape onto the mirrors. As I saw in that other video, you're supposed to put it here. So I will just put it on here now just to see if I hit the mirror, the middle of the mirror. But of course I will avoid to touch that mirror with the tape. That is quite important. And there we are, pretty much exactly in the middle. But isn't too bad. Now let's try to move this. And you see that the dot is moving quite a bit. So we are moving, which is not good. So we need to find the sweet spot here. So I have to undo these screws again and move everything a little. Move it. You see that when I move the sled, the laser moves a little bit. But the thing is that depending on where I push, it moves more and less. And I just check that the whole sled is moving a little. And that is because of these little wheels here. They are sitting on an axis that is not centric. You see that this is not centric, but this is off center. So there is another adjustment point. And then I get me some pliers. And then I will turn this That's way better. So it goes a little bit up there. As you can see, the dot is not moving at all when I move the sled. And I can move my fingers here, so you see it's not a still frame. It is actually very, very stable, and it remains at one spot. I put a little piece of tape in front of the laser tube. I take care to not touch the actual output. I just put it on really on the glass rim. So as here on the actual mirror, I don't tape it on the mirror, but just on the end cap or on the actual bracket. And now I will remove this piece of tape here, and now I can start adjusting this mirror. Now, a pretty cool thing is that I can slowly move the sled, and while moving it, adjust the mirror. So that helps a lot to get rid of every little shifting in the axis. I think this is not too bad. Let's see what this does on the laser tube. Now here we need a little correction. Now the unit is plugged in again, the water pump is running. Let's put on some safety goggles and let's try to align it the other way around, from the laser over the mirrors to the laser head. And I will follow John's tutorial here. So as I said, you can check that out. I don't show you this in detail now, but I turn on the unit and I glued a little bit of paper here to the bracket, not to the mirror, but to the bracket. Let's see, when we just turn down the power. Let's turn it down entirely and let's slowly crank it up. Okay. And I see something pretty bad. I just fired the laser into the belt. Now let's hope that this did not burn through. Well, okay. Then let's go through the whole process again the other way around and maybe forget about the reverse calibration here. Okay. I got everything lined up. I put in a piece of wood. I go to the most, the southernmost point of my laser cutter, and I will try to redraw the same thing I did last time. Tico, is it Tico? I try your suggestion of using 50 milliamps and a 10 millimeter speed per second. So I already set that up here, and maybe I should put back the lid. Now this is awesome. This is pretty awesome. Okay, so this is 4 millimeters, guys. This is not 3 millimeters. And even that cut went all the way through without issue. I haven't seen results like this in a long, long while. Especially not in what I called the dead end of my laser. Like this whole area that I never could use for years. I barely can remember using it anytime because it always made problems in this corner here. And I know, of course, that this usually is a problem of alignment. I aligned this thing many times and I made sure the mirrors are clean and the lens is clean, but it always caused problems in that corner. And now I found out what the actual problem was. This morning I was disassembling the sled. I took off the whole sled to clean it, also to clean the rollers and everything. And when I took off this aluminum top plate here, I saw that, wait a second, I saw that this little bolt here, which connects the upper to the lower part, the whole threaded end was broken off. So I had to drill it out, I had to tap a new thread in it, and I replaced this with the same thing but made out of steel. And now apparently it works. So my theory is that because of this cable chain here, every time the laser was a little bit further away, due to the weight, the whole thing was moving, and of course that brings everything out of alignment. That little laser thing I built it, well, it came in pretty handy to align the whole sled, because the sled is movable and adjustable in so many angles. You can adjust the rollers, because sometimes there is a little play here. You can fix that. You have to align those 3 screws. Well, you have to align the laser head. You can twist the laser head. So there are so many angles where it comes really handy when you have a red dot in your mirror where you can really see what you're doing. Still, I had to recalibrate the whole thing. Well, with the classic with the classic tutorial. Let me say thank you to some of my subscribers here, because you guys made me disassemble the whole thing and just realign everything and check out what the problem is. So thanks Daniel, thanks PunkBG, thanks the Tico or T3Co, thanks Frank, thanks Ian, thanks All Inclusive, Brainy Bren, Pyron, and Justin, and many, many more to help me out and give me some very interesting input. I think I need to play around some more with this thing now. I'm very curious to see how it performs on acrylics now. So thanks so much, everybody, and I hope you liked it. I see you on the next one. Until then, see ya.